Hi everyone, it's Mrs. Brimlow, and today I'd like to go over solving systems of equations with you by graphing formally. So in this video, we're going to do a real-world example together, making connections to the different types of solutions you can find when working with systems of equations. So in our last lesson, we did an investigation to see what systems of equations were, what they look like on a graph, and how we figure out the solution. And we learned about two different solutions types. One, what we call one solution, where there's a point of intersection being the common point shared between your two functions. We also have no solution when the lines are parallel and it doesn't appear they'll ever cross. There's actually another type of solution which we're going to talk about through this lesson. So if you could turn to page 9 if you have the packet. If you don't have it yet, that's okay. I've linked this as well as put it in Kami. Okay. So solving systems of linear equations by graphing. So we have this map over here of an area of a city. And it has some different roads that you're looking at and comparing. So they're calling the equations or lines the different roads and talking about their solution. So for example, Newton and Shirley. If I find that here, I have Newton Road right here and Shirley right here. Point A is where they would intersect. That's their common point. Okay. And then an example of no solution, General de Gaulle right here and Manhattan are never going to touch. Okay. So they give you a couple more streets that you're going to figure out what the solution is, and then they give you the solution, and you're going to find out what streets would match that. Okay. Then they have a couple of questions for you to answer, and then you could come back. So I'd like you to pause the video now that I've gone through the directions. Go ahead and go through and answer these questions, then come back when you're ready. All right, now that you have taken some time to go through these problems, I'm going to go ahead and go through the solutions and kind of go through these summaries with you. So we're looking for Whitney and we're looking for Carol Sue. So Whitney and Carol Sue intersect here at point D. Okay, so this is what they share together, this corner. Franklin and 428. So here's 428. Franklin's over here. These lines are parallel to each other, so they would have no solution. They would never cross paths. Okay. Then we have 428 and Carol Sue, and they cross here at point E. Point E. Okay. So now they give us the solutions, and we have to come up with the roads or equations. So point B is right here, and it looks like Whitney and Highway 90. So Highway 90 and Whitney. Okay. Point D, we actually already found Whitney and Carol Sue. And then we need an example of no solution. So there are multiple answers to this. I actually found two different answers. I'll share them with you. So one example I found was Woodland and Franklin. Another one I found was Whitney and Shirley. So these are two examples, and there's more than this. I can see at least two more just looking at this, but there are plenty more to choose from. These are some examples of roads that are parallel to each other. They'll never cross. Okay. So what does it mean for a point to be a solution to two equations? So if we think about it in terms of roads, it's where the two roads intersect. They'd have an intersection of some sort. So it means both roads go through that intersection. Okay. Now, what does it mean if they have no solution? So what we found through this example and through our investigation is that they will never cross. They're parallel to each other. So it means the roads never connect because they are parallel to each other. So those are the two kinds we saw last week, and I just like the map example of this, okay? So last question, extension, and also kind of talking and thinking about our last type of equation. Is it possible for two equations to have more than one solution? So what would that look like? So far we have one solution where they intersect at one point. We have no solution when they never connect. So now we want to see, is it possible to have multiple intersections? How would it work for one road to have multiple intersections with another road? So one on top of the other. The only way that would be possible is if it was the same road, okay? And if you think about it, typically it would be a road that we'd see the same name for, or same road, but two different names. So for example, if you think of the road that Wickford is on, we call it either Tower Hill Road or Route 1. It's the same road, but with two different names. So that would be the only way we could have something that has more than one solution. So it would look like two different equations, but when you simplified them, they would be the exact same. And in order to have more than one solution, we'd have to have a whole line that overlapped itself. Therefore, it would have all the same solutions. So we'd say it's infinite, okay? So yes, if they overlapped or intersected in multiple spots. An example of this would be Tower Hill Road and Route 1. Same road, different names. Okay. So, if you turn to the next page, page 10, this is really good practice right here. I'd like you to try. And if you have any questions,